Okay, so we talked a little bit about probability in the last hour. I want to kind of tie it back into the big highlights then of the statistics that we've talked about. One thing I want to review is if I give you a table. Let's say we're looking at number of classes taken by students. And so, well, you can't go zero because if you're taking 0 classes, you're not a student anymore. Let's say 1, 2, 3, 4, or 5 classes. And the frequency, let's say that we have, of the people that we surveyed, there's 18 people taking 1 class, 27 taking 2 classes. We have 35 taking 3 classes, 18 taking 4, and 2 taking 5 classes. What's that? Yeah, it all depends. They might be 1 or 2 credit classes. Who knows? So anyway, what I want you to do off of this set of numbers, I want you to find the mean and the standard deviation for me. Let's see if you can remember how to do that off of a data table like this. Let's check the mean to make sure you're good that far. If we're not, then it doesn't make sense to go on to the standard deviation. To find the mean, we need to add a column here, which is what? The number times the frequency. So 1 times 18 is 18. 2 times 27, 54. 3 times 35, 105. 4 times 18, 72. And 5 times 2 is 10. Now there's 2 columns that we need to total up. We need to total up this one that we just did. So we're going to get 72, 177, 249, 259. And then our frequency column, we need to find out what n is. N equals, we add that up, we get 45, 80, 98, 100. How do we find our mean from those numbers? The mean is the 259, it's this column, divided by n, the frequency, total frequency. So 2.59 is the mean number of classes taken. How many of you came up with 2.59? Okay. So now if you didn't come up with 2.59, you'll have to go back and change your work a little bit on the standard deviation. But let's go ahead and I'll let you continue with the standard deviation then. And I'll even give you a hint here. The next column is the number minus the mean. So this would be 1 minus 2.59 or a negative 1.59 here. And I'll let you keep going with that. Let's see how you're doing. So this is 2 minus 2.59 is a negative 0.59. Actually, you know what? I'm going to do this smart. Just to make it faster. That's not it. There we go. I'm going to cheat. Okay. So this is going to be the number minus the mean. Let's see if I can spell. This is going to equal this minus 2.59. So there you go. It's been subtracted from each of them. Next, we're going to do what? What's our next step? Square it. So squared. There, they've all been squared. What's next? The squared number times the frequency. So we've multiplied our square number times the frequency. What's next? Well, now we're back on track to what we were doing for a standard deviation for just a list of numbers. The next step would be to add them up. So we have a total of 108. Then what? Divide by n minus 1. So n is 100, so we're going to divide by 99. And then the final step. Find the standard deviation. We're taking the square root. So 1.04, 1.05 is the standard deviation of this set. On a test, I may or may not ask that. I haven't decided yet whether I'm going to stick with just individual numbers or if I'm going to do a data table like this. What I might do is do an extra credit question with a data table if I don't put it on the test. Okay, enough of that. Okay, so let's say that the average household, I'm looking at food expense, monthly food expense. For a family of 4. Let's say the mean monthly expense is $580. The standard deviation of $140. I want you to find the percent that spend less than $580. The percent that spend more than $860. The percent that spend less than $720. And the percent that spend between $300 and $720. So find those percents for me. So let's take a look at this. First of all, how are we going to determine this? Well, anytime you're given a mean and standard deviation and asked for a percent, it generally is hinting at using the bell curve. And how do we know what numbers to put on the bottom of the bell curve? The mean and the standard deviation. So what's going to go in the middle of this curve? 580, the mean, right? What's going to go here? $580 minus the 140 minus the standard deviation is 440. This one will be minus another 140 is 300, and this one's going to be 160 minus another 140. That's eating awful thin for the month then, for a family of 4. Going this way, what's this number going to be? Yep, which is 580 plus 140 or 720. This would be 860 and $1,000. That's a lot of eating out.
Either that or they really fancy us.
That's a lot of eating out. That's a lot. Otherwise, you're cooking a lot of lobsters at home. And of course, these percents do not change. They're always the same.
Either that or you're having happy hour steak.
That's even hard to eat enough steaks to make that go. But anyway, so for number 1, less than 580. Well, 580 is the mean, so the percent that would be less or greater than that would be what? Less than 580 would be these percents, and it should add up to 50%. The mean should always cut the data in half. There should always be half less and half more. So 50% less, 50% more.
What if it's like 40,000?
Yeah, we don't want to talk about it. More than 860. Where's 860? We add those together. That's going to be 2.28%. Less than 720. Here's 720. We add these up. We're going to get 84.13%. Between 300 and 720, well, that goes, I'll find a different color. 300 to 720, we add those up and we get 81.85%. I believe that adds up to.
Or 81.9?
85. How many of you had all 4 of those right? I had at least 3 of those right. How many of you have no clue where those 4% came from? I want me to go over that again. Okay. So the key here is these percents in the curve are always going to be the same. In fact, I could draw the curve before I even define the problem. So I can do this. I can draw the bell curve. And I can put those percents in there. 34.13, 34.13, 13.59, 13.59, 2.15, 2.15, and 0.13, 0.13. What does change is the numbers that go down here, and those are going to be based on the mean and standard deviation for our data. So let's say we look at tuition costs, the mean cost per credit for schools. Let's say that comparing different schools, the mean cost per credit is $184 per credit with a standard deviation of $21 per credit. So, it don't matter. We'll go technical colleges. How's that? 2-year technical.
Are you going to ask us to remember those percents at any time?
You'll be able to look them up in your book. They're in your book. What page are they on? I don't have the page written down anymore, but they are in your book. It's in chapter 6, I believe, of your book. Or you can look them up in your notes if you want to. I mean, you can always use your book and notes on your test. So anyway, what's going to go down here at the bottom of the curve, you have to start in the middle because that's your mean, which is the 184. This number right here. So that's where you start, is in the middle. And as you go to the left, you subtract the standard deviation at each step. So you have a standard deviation of 21, so at each step we're going to subtract 21. So starting at 184 minus 21 is 163. Next step, we subtract 21 again from the 163, that's 142. We subtract it again, that's 121. Make that line a little straighter. Going the other direction, we're adding the standard deviation. In this case, we're adding 21 at each step. So 184 plus 21 is 205, plus another 21 is 226, plus another standard deviation is 247. So now that we have those numbers in down here, now we can ask questions. For example, what percent is between 163 and 247? So here's 163, here's 247. If we add those percents up, we get, so the 34, come on, 34.13 plus 34.13 plus 15 or 13.59 plus 2.15. That should equal, actually comes up to exactly 84%. If I wanted to know what percent is less than 205, take this out. Here's 205. Less than that is going to be all that. So I'd have to add those numbers up. 0.13, 2.15, 13.59, 34.13, 34.13. So 0.13, 2.15, 13 plus 0.59, plus 34.13 plus 34.13. That should add up, looks like 84.13%. I might ask what percent will be larger than 142. So again, I'm going to get rid of this. Here's 142. Larger is going to be this way. So I have to add all those numbers up. 13.59 plus 34.13 plus 34.13 plus 13.59 plus 2.15 plus 0.13 adds up to, what is that, 97.72%, I believe. Does that make more sense? Okay. It is it's a tough concept because it's hard to see that, you know, the percents always stay the same. It's these numbers down here that change based on the mean, which is always that center number, and then the standard deviation as you go each direction. Any other questions? Okay, well, that pretty much wraps up everything I wanted to talk about on statistics. So I'll give you guys the last 20 minutes here if you want to get started on your homework, or there is a new quiz that is due tomorrow. That is Wednesday at 11:59 p.m. And there's new homework. It is due for next week, Tuesday. So like I said, if you want to start working on the new homework or on the quiz, the computer lab next door here is open, or in New Richmond. If you can find a computer somewhere to work on or whatever, I will be in the room here until 8:20 to help you out if you have any questions.